Hey everyone, welcome to another video of hok'stutoring. I hope you're well. Today we'll be going through a topic video where I'll be talking through and explaining through the chain rule. So this is chapter 9 of your maths method textbook as part of the differentiation topic. And if you're doing specialist maths, it's also a very important technique that you need to know. So today in this video, I'll be explaining through what exactly is chain rule, when can you apply chain rule, how to apply chain rule, and the most important part I believe is going to be the shortcuts on how you can speed things up when you're applying the chain rule. So this is going to be very crucial towards your SAC and your exam where time is precious. So make sure you watch till the end to find the useful tip. So without further ado guys, let's get into the video. Chain rule. So first of all, what is chain rule? So chain rule is a differentiation technique, probably the most important differentiation technique you're going to need to know for methods in specialist maths, because this is going to be used everywhere. Okay, it can be used as a question by itself, it can be used as a question in combination with your other topics that you're going to learn later on. So it's very important that you know this. So chain rule applies where you have essentially a composite function. So we learned that earlier in the year. A composite function is where you have one function within another function. So in this case, the general form is g of x inside f of x, or you say it as y equals to f of g of x. So an example of this, as we've already discovered earlier in the year, is you could have an equation where y is equals to x squared plus 1, for example. So that's a quadratic, and it's inside maybe a cubic. So in this form, that's an equation that you can potentially apply chain rule if they ask you to differentiate. Another example could be y equals to sine of x, and then this is to the power of 4. So in that case, you have a sine graph, which is a trigonometric function in a quartic. So again, that's a composite function, and if they ask you to derive, you can apply chain rule. Vice versa, you might also have something as a sine graph, but inside that sine graph, you have a quartic. So very similar to this, but again, it's different. So you've got two of the same graphs, but it's just, which one's in which one. That's pretty much it, okay? So in all these cases, guys, these are the forms where you can apply chain rule. And you can see there's so many varieties, so many different types of questions the teachers and the examiners can give to you. So that's why it's very important you know how to use chain rule. So now that you know when to use chain rule, how can we apply it then? So chain rule is a very simple, I suppose, formula. So if I give you a function where y is equals to f of g of x, and obviously we're learning the differentiation topic, so you want to derive it, the very simple formula, and there's multiple forms of this. Textbook will teach you a different one, which I'll write eventually, but I guess the shortcut here is you have g dash of x, meaning the derivative of the inside multiplied by the derivative of the outside function f dash, but then you retain the inside function g of x. Now it sounds like very confusing here, but as we go through the example, you'll find out what this form exactly means. And the other variation involves u and v, which we'll go through an example. I think that's the long method. Well, it's essentially the proper method of doing it, but it takes a lot more time. So guys, I'm gonna go show you an example, and we'll find out how to apply this formula right here. So let's take our function as y equals to something very simple, x squared plus 2x plus 1 to the power of 3. So, one way of differentiating this is you expand the whole bracket, and then you apply, just differentiate normally, polynomial, just bring the power down, minus power by 1, that's pretty much it, right? But again, that's a bit too long. So what we want to do is we realize that this is a composite function. It's a quadratic inside a cubic. So you can apply this formula right here, the chain rule formula. So the long way, the traditional way of doing chain rule is you let the inside function, okay? So I call whatever function is in the inside, so gx in this case, that's gx, or usually I just call it inside function. And it's good to name things so that it's easier for you to understand. If you want to call it gx, that's fine by you, or if you want to call it an inside function, that's also perfect. And then obviously the outside would be the cubic, so then I'll call that the outside function, or in this case f of x, okay? So you let u, the traditional way is you let u equals whatever function is in the inside, which is x squared plus 2x plus 1, which would make your equation being y equals to u to the power of 3, because now that quadratic is replaced by u. And to find dy dx, they take advantage of the fact that, if I derive, y in terms of u, I get dy du, and if I multiply it by du dx, so in this case, I have u in terms of x, if I derive that, I get du dx, then the du's will cancel out and you end up with dy dx. Can you kind of see the pattern here? So that is the traditional way, and we're just going to go through it. You'll see the steps step by step and how long it might take. So dy du in this case is 3u squared. So you bring the power down, which is 3, and then you minus the power by 1. Very simple. And then du dx, the same thing. You multiply it by, well, we look at u, we look at x, we derive things. This is polynomial differentiation. Apply the same method. Bring the power down, 2x, and then this 2x here is just becomes a 2 because that power is 1. So you bring the power down, which is 1. 1 times 2 is 2, and then minus the power by 1. 1 minus 1 is 0. X to the power of 0 is 1. So you end up with 2 times 1, and that's 2. Plus 1 just disappears. And then you have this as the n, 3u squared times 2x plus 2. Well, we want the derivative in terms of x. See, it's in terms of x, not in terms of u. So what you do is you replace the u with whatever, in terms of x, whatever x you have. So you get 3 times by x squared plus 2x plus 1. And then you multiply that by 2x plus 2. And then your final answer, if you want to simplify everything, you can take the 2 out. So in this case, you get 3 x squared plus 2x plus 1 multiplied by 2x plus 1. And if you want to make it look really nice, you can multiply the 2 and 3, you get 6 x plus 1 x squared plus 2x plus 1. So guys, that's how you apply the chain rule using the traditional way. You let u equals to whatever functions in the inside, and then you let y equals into let y be an equation in terms of u. Use this formula right here, the important one, and you'll end up with the result. Make sure it's in terms of x. So that's chain rule using the traditional way. So I want to show you in this video, I guess the more important part of this is the shortcut, because you get a lot of chain rule questions, trust me, when you're doing exercises in your textbook, or you're doing exams, or you're doing SAC, you'll be pressed for time. So there has to be a quicker way of doing it, and there in fact is a way, and that's applying this formula right here, okay? Make sure that you note down this formula, because it'll be very convenient, I suppose, if you know how to apply it. So again, I'm going to come back to the same question. I'm going to put on the right hand side, y equals to x squared plus 2x plus 1 to the power of 3. Now remember, with chain rule, you just need to know, which one is the inside function and which one's the outside function. We've already determined over here. This is inside, and the cube is the outside function. Okay, so once you know what's inside, what's outside, it's then very simple to apply the formula. Okay, so let's have a look at it. Now with this rule, when you're using the chain rule, you derive the you get g dash x times by f dash gx. So essentially gx is the inside function. That means they want you to derive the inside function. So dy dx, right? We're going to skip all the u's and the dy du's and all of that. We're going to go straight to the answer. So inside function is x squared plus 2x plus 1, which we have determined over here. If you derive that, what would you get? Well, we know we did that before, but again, this is just a polynomial. So you bring the power down, minus power by 1, and that's what you get. So 2x is the first one, and then plus 2 is the second part. Plus 1 disappears, that's gone. And then you multiply, okay? So that's g dash x, you're done. You just, inside, you just derived it. Now what about the outside? Well, the outside, you just have to think, okay? So it's just an x cube. It's just something cube. Imagine this function is an x. It's just, you don't need to touch it, okay? So you leave it by itself. X squared plus 2x plus 1. Imagine that's an x. It's just a function by itself. What you're doing is you're deriving the outside. So the outside is a cube, right? So if you have y equals to x cubed, how would you derive that? Well, you bring the power down, 3, minus the power by 1, and you get 2, and then you leave whatever's in the middle, okay? Whatever is that function, just leave it. So in this case, x squared plus 2x plus 1 is the one that you want to leave. and we're only deriving the power essentially. So you bring the power down, which is 3, minus the power by 1, and you get 2. And then there you have it, guys. It's pretty much the same thing as what we just got here over here. So you can then try to simplify. You can take the 2 out, 2x plus 1 multiply by 3x squared plus 2x plus 1 square. And if you don't want to write that multiply because you might get it confused as an x, you can just put a circle like a dot, and then you can just multiply it. So 2 times 3 is 6, and we get the same exact answer as the traditional method, but if you can see, it's a lot shorter. Okay, so you want to be able, by the end of this video, and then hopefully after some more practices, you want to be able to apply this shortcut every single time when you're doing exercises, because it's a lot faster. It's going to cut down your amount of time that you're going to use chain rule, and makes it more efficient. Okay, so that's that, guys. We'll go through maybe just one more example, and again, this one example, we're going to use a shortcut just so that you know how to apply it on other kind of functions. So with our second example, let's just say we have y equals to 2e sine of x. So there's normal polynomials here. Looks very different. You've got an exponential and you've got a sine graph. And guys, just before we even start this example, make sure you know how to derive a sine function. Make sure you know how to derive an exponential. If you're having troubles with that, please leave a comment down below, and I can make a video on that. But otherwise, let's get into the chain rule of this question. So if we want to derive this, remember, we need to determine what's the inside function and what's the outside function. So I'll give you maybe a couple of seconds to think. What is the inside and what is the outside? So you've got essentially two functions here. You've got an exponential and then a sine graph, okay? Right, so in inspecting this, we know that the sine function is part of the exponentials. It's the power essentially of the exponential. So the inside is the sine graph, okay? So that is what I call the inside function. And then you have the exponential, and the 2 here is also technically part of it. You can leave it out, but you can also leave it in. That's part of the outside, okay? But and then if you want to think of it the other way, if I had a graph which is y equals to sine of 2ex, for example, then the inside would be this one. This one's a bit more obvious, and then the outside is the sine function. So just think, which function is inside which function. So now that we know what's inside, what's outside, it's really easy, guys, to differentiate this. So remember, the rule is derive the inside, multiply by, forgot that dash over there, multiply by the derivative of the outside, and then you leave the inside function the same, okay, when you're deriving this. So let's have a go. What is the inside? Inside is sine of x. When you're deriving the inside, what would you get? Well, derivative of positive sine gives you positive cos, okay? So then bingo, done. You've just done the first part. Now the second part is the derivative of the outside. So what's the outside? So think of it, 2e to the power sine of x. Now sine of x, just leave it, that's whatever, just leave it as it is. That's just part of your outside function. So think of it as y equals to 2e to the power of x, okay? So when you're deriving this, what would you get? So in this case, you get dy dx equals to essentially the same thing, right? Essentially, you derive that power, you bring it down, but then you get nothing, okay? So you get 1, but then 1 times 2 is still the same. So when you're deriving this, you get the same kind of function. In this event, if we bring it back to our chain rule, you get 2 multiplied by e to the power of x, but instead of x, just replace it again with whatever was in the inside. You leave them the same, okay? That's what this means. You derive the shell of the equation, in this case e to the power of x, and then you just replace x with whatever's in the inside, okay? Just imagine that sine of x was an x. And then there we go, guys. That's pretty much it. That's how you derive this function. It looks really confusing at the start, where you have a sine inside an exponential, but it turns out to be very simple. 2 cos of x multiplied by e to the power of sine of x, and then that is it. That's how you apply the shortcut of the chain rule. So guys, I hope you find this video useful. This is going to help you a lot, and I'm hoping it does for your exam and for your SAC. And if you have any questions, please let me know, leave a comment below, and if you did enjoy the video, please leave a like and subscribe to hok'stutoring. I would greatly appreciate that. Otherwise, thank you for watching, and I'll see you in the next video where I'll be talking about product rule and quotient rules.